Hi everybody, hope you're doing well. This video is going to cap off week 4 of Survey of Math. So this will be the fourth section here of Unit 5, which will deal with how to write equations of parallel and perpendicular lines. So we're going to go through, and basically it's going to use a lot of the other things I've already reviewed in this chapter. We've reviewed parallel and perpendicular slopes. We've reviewed how to write basic equations in point, slope, and slope-intercept form, and now we're just going to review and combine those two concepts together. So the first slide here, we'll go through parallel. The second slide, we'll go through perpendicular, and then we will cap it off there. So given the info below, we're going to write parallel equations. So again, the key word being parallel. Parallel means the slope has to be the same. So number one, I give you the original slope and a point, okay? Here's the thing. If I give you a slope and I want something that's parallel, the beauty of it is the slope of a parallel line is exactly the same. So these problems are a little bit easier because you don't have to really think too much. If it's parallel, it's going to be the same slope. So especially if I give it to you right off the bat, you've got that, you've got the point it should pass through, and we can basically start writing the equation. So always start in point slope form. So remember this guy, y minus y1 equals m times x minus x1. Plug in negative 3 for y1, so it'll be y plus 3. 2/5 for m. And x minus x1 will be x minus 10. Remember, when we write these, and on the IXL that you're going to do, it's going to want you to put these in slope-intercept form. So we're going to get the y by itself. First thing we do, distribute. So we'll get 2/5 x minus 4. And then we'll subtract the 3. Y equals 2/5 x minus 7. That would be the equation of the line. That would be parallel. Same thing here in number 2. Only difference is I give you 2 points. Well, if I give you 2 points, that means you have to go find the slope. So let's find the original slope of these 2 points. So we'll have 5 minus negative 3, so 5 plus 3. And then 5 minus 1. So it'll give me 8 over 4, which equals 2. So if my original slope is 2, that means my parallel slope is also 2. Okay? So use those 2 points to get the original slope. If I want something that's parallel to it, let's say it passes through, let's just make up a point here, negative, we'll make it even easier, 3 comma 8. Okay? So I want a parallel line that passes through the point 3 comma 8. I'm going to take the slope and the point, and we're going to go ahead and write our equation. So we're going to start off in point slope, just like we did with the last example. So I'd have y minus 8 equals 2 times x minus 3. Distribute the 2. And then add 8, getting me a final answer of y equals 2x plus 2. So basically, those are the 2 possible combinations you could see. Giving you a slope and a point that it needs to pass through, or if you are given 2 points, use them to find a slope and a point that it will pass through to write your equation. But parallel, again, same slope. Once you know the slope, you already have it to go write your new equation. Just make sure you use the point that it's telling you to pass through, because technically that's how you're going to make your new line. Okay? Now, perpendicular, that's the one where you have to do a slight more amount of thinking, as we've already gone over. Perpendicular means you need slopes that are opposite reciprocals. So, if we're going to find perpendicular, so let's say I give you an original line with a slope of 6, okay? I wanted to pass through, so I'm going to add that detail in, because there is a difference since we're using it as a different point. Telling you the original line has a slope of 6, I want a new line that's going to pass through the point negative 3, 0. The key is, though, I need it to be perpendicular. So perpendicular is opposite reciprocal slopes. So if I have a slope of 6, the opposite reciprocal would be negative 1 over 6. Remember, you flip the number, change the sign. Once I change that slope, I've already got the point it passes through, I have my slope. I now repeat the process from the other 2 problems. So once again, we start in point slope. Y minus 0 equals negative 1 over 6 times x minus negative 3. We'll call it x plus 3. Now, since it's y minus 0, Subtracting by 0 doesn't really do me any good, so I could just call that y. Distribute at negative 1, 6. I get negative 1 over 6x. Minus negative 1, 6 times 3 would be negative 3 over 6. That reduces to negative 1 half. Since this is only slope-intercept form, I don't care, again, that I have fractions all over the place. We can leave that be. This is not being written in standard form, so I can just leave this alone, and there's my final answer. Last one, same idea. So I'm giving you two original points here, and we're going to say this will pass through the new line. Let's go with 2, 7. Again, just kind of making up a point there. So I give you two original points. I need something perpendicular to it. So in order to know what's perpendicular to it, I need the original slope. So I'm going to find the original slope by using my slope formula, which would be 3 over negative 1, which is negative 3. If I want what's perpendicular to it, perpendicular to negative 3 would be positive 1/3. So I have my new slope. I have the point I needed to pass through. Now we can go ahead and write our equation. So, use my point slope. Y minus 7 equals 1/3 times x minus 2. Again, I'm using the point that it passes through in my equation here. Distribute the 1/3. So 1/3 x minus 2/3. I'll add the 7. And if I add 7 to that, if my mental math is correct, that should be a positive 19/3. Again, I'm going to leave everything as a fraction, and I would suggest, too, making sure you leave things as fractions as well, if that's how they come up. I believe on the IXL, it's not going to take decimal answers. So if you do run into a place where there's a fraction, use a calculator, especially if you're not so good at converting this. Make sure your fractions are good. But that's your short review there of parallel and perpendicular equations. Parallel, again, you're going to keep the slope the same. That should be pretty easy. Perpendicular, you have to make sure your slopes are opposite reciprocals. It's really easy to make a goofy mistake in these problems because there are several steps. I would highly suggest, again, when you're doing the IXL for this, take your time in solving these, okay? If you try to rush through them, you're going to make goofy mistakes and constantly keep hopping backwards while you're trying to make progress. So, with that being said, your IXL assignment that goes with this, again, we remain in level K. Not level.K, level K. Only one topic for this, S.26. Target score, as always, take it to an 80. So, give that a try. Again, take your time in going through writing those equations. Make sure you're keeping up with the other IXL assignments from earlier in the week. If you haven't started those yet, please get on those ASAP. You don't want to have a whole bunch of these building up as we start approaching May and getting close to the end of the year. So, again, if I can be of assistance, shoot me an email, send me a message on Schoology, stop by my office hours on Zoom. I'll be more than happy to help you. Otherwise, thanks for watching. Stay safe, stay healthy, and we'll see you next time.